Oh, sorry about that. Now, the other key point of an exponential, aside from it increases at a rapid rate on the right hand side, it decreases at a very sharp rate as well. Now, it looks like this graph will reach 0 very, very quickly. Now, the key thing is, though, this graph will never touch y equals, or the x-axis. It can't ever touch the x-axis. Now, the reason being is, if it does touch the x-axis, what it means is 2 to the power of something gives me 0. Now, you can think as hard as you can, but 2 to the power of nothing gives me 0. That won't ever work. So this graph can never, ever, ever touch the x-axis, and hence we call the x-axis, so this horizontal line, we call it the asymptote. So it's a line at which the graph appears to get close to, but it can never, ever, ever touch. So in this case, for y equals 2 to the x, the asymptote is at y equals 0, aka the x-axis. So when you sketch an exponential graph, draw it so that it's a steep increase on one side, but then on the other end, it looks like it will be really, really close to touching the asymptote, but it can never, ever, ever touch the asymptote. Now let's look at some variations of the exponential graph. So sketch another one again. So label your axes, x horizontal, y to the sky. So let's look at the one the example we just looked at, which is y equals 2 to the x. So we saw that it looks like steep, So when x is 0, y equals 1. So it's a pretty steep rise. And then it looks like it'll get very close to asymptote, but then it won't ever, ever touch it. Like that. Now that is y equals 2 to the x. So what happens if we throw in a negative x in front? So y equals a negative 2x. Well, if that happens, it turns out that it's a mirror image of the blue curve that we just drew. So before it passed through 1, now it's going to pass through negative 1. So what happens will be, it'll be literally a mirror image of exactly what we just drew. So that's the effect of what happens when you throw a negative in front of an exponential function. Now another variation that you might see is what happens if we have y equals 2 to the negative x. What if we throw a negative in front of the x, the independent variable, instead? Well, what happens at that time is, rather than being mirrored in the x-axis, it'll be mirrored in the vertical, the y-axis. So that it'll look like this. Oh, that doesn't look like a very good mirror image. Let me try that again. There we go. So there's still a steep increase on one side, and on the other side, it'll approach the asymptote, the x-axis, but then it'll never, ever, ever cross the asymptote. And so if you put a negative sign in front of the base, then it just mirrors it to the bottom. Whereas if you're putting a negative sign in front of the x, which is the independent variable, then it just mirrors it on the vertical axis. So key point of exponential, they have an asymptote, which is a line that it looks like it's going to get really, really close to, but it can never, ever, ever touch. So when you draw an exponential graph, make sure that you don't draw it so that's like, oh, I'm going to cross the x-axis, because your graph cannot touch or cross the asymptote. So let's do a few examples. Example 1. So let's sketch the following and label the y-intercept and the point when x equals 1. So we're going to compare the effect of these three graphs, namely 2 to the x, y equals 3 to the x, and y equals 4 to the x. So what happens to these exponential graphs as the base value increases? Does it get steeper? Does it get less steep? Does it get more flat? What happens? So we're going to investigate that. Now, when we're sketching a graph, we really need 2 points to be able to sketch a graph. So let's find 2 points to tell us to work out the y-intercept and work out the point when x equals 1. So for y equals 2 to the x, y-int occurs when x is 0. So when x is 0, y equals 2 to 0, which means it's 1. So we get the y-intercept 0, 1. And then they also tell us to figure out the point when x equals 1. So when x equals 1, what does y equal to? Y equals to 2, so we have the point 1, 2. Let's do the same thing for the other graph, which is y equals 3 to the x. Let's work at the y-intercept. So y-int when x equals 0. So y equals 3 to the 0, y equals 1. So I have the point 0, 1. And then when x equals 1, what does y equal to? 3 to the 1 equals 3. So I get the point 1, 3. And then the other graph is y equals 4 to the x. So y-int when x equals 0, y equals 4 to the 0, which is 4, so we get the point 0, 1, and then when x equals 1, y equals 4 to the 1, which is 4, so we get the point 1, 4. So essentially we have 1, 2, 3, 4, 5, 6 points to help us plot our 3 different graphs. So let's draw a set of axes with a ruler so you get straight lines. Label your axes. X rolls across, y to the sky. So we need to go across to 1, 2, and then 4 up. So you'll notice that all of the x-intercepts occur at the same point, 0, 1, 0, 1, 0, 1. So we know that all these 3 graphs pass through the point 0 across, 1 up. So we've got that one there. Now for y equals 2 to the x, when x equals 1, y equals 1, 2. So 1 across, 2 up, so that's 1, 2. So remember, on one side it's a steep rise, whereas the other, it tries to get really close to the x-axis, but it never touches. So steep rise, make it look like it's going to touch the x-axis, but never ever going to touch it or cross it. Getting very close to it though. So this is y equals 2 to the x. What about y equals 3 to the x? Well, we have the point 0, 1, which we've got already, and 1 across 3. So it's 1, 3. It's going to pass through 0, 1, and then pass through 1, 3. Again, it's going to have a steep rise, and down the other side it's going to get close to the asymptote but never touch it. And then our last one is 1, 4. So 1, 4. So another steep rise, and then getting close to the asymptote but never ever really touching it. So a pattern that you'll see is that as the base value increases, the graph gets steeper on the right hand side. So we can make a note about that. So as the base value increases, the graph gets much steeper. So that's the effect of changing the base. Let's do one more question, which involves us solving exponential equations like last time. So example 2, find the intersection of y equals 2 to the x and y equals 8. So intersection means we're trying to equate or make equal these two equations. So we've got y equals 2 to the x and we've got y equals 8. So essentially we need to equate 1 and 2 if we're trying to find the intersection or where these two graphs cross over. So essentially 2 to the x equals 8. Remembering from index equations, try and turn them both in the same base, because when the same base we can equate the powers. So in other words, x equals 3. We're trying to find the intersection point of these two graphs, so we need to find the x and y value of this point. So we worked out that x is 3, but what is y going to be? Well, 2 to 3 gives me 8. So therefore the point of intersection is 3, 8. And that's pretty much it for exponential graphs. So recapping, the key thing with exponential graphs, you have a base value a, you have two unknowns, your x and your y. Now on one side you will have a very steep growth, whereas on the other side your graph will appear to be very close to the x-axis, but it can never touch or cross the x-axis. It'll get really close to it, but it can never touch or cross. And that's what's called the asymptote. It's the line which it can't ever touch or cross, but it'll get really, really, really close to it. And exponentials is something that grows or decays really steeply. Now, the effect of negatives is that if you put a negative in front of the base, it becomes flipped on the x-axis, whereas if you put a negative in front of the x, it gets flipped in the y-axis. The effect of changing the base value, oh, I forgot to label the graphs here. So blue is y equals 2 to the x, red is y equals 3 to the x, and green is y equals 4 to the x. So the effect of increasing the base, as the base value increases, your graph gets steeper and steeper. But again, on the other end of the graph, it can't ever touch or cross the asymptote or just get really, really, really close to it. Now, when you're sketching these exponential graphs, you can always use your graphics calculator to check, or Desmos to check what it looks like. So just put it in your calculator or Desmos, and then you can easily verify whether you sketched it right or wrong. And even using some points, a table of values to graph also may help you get the general shape of the exponential. And that's pretty much it. So to-do list is exercise 7I. Okay, have fun.